Have you ever gazed at the stars and wondered about the vast expanse of cosmic history? What if you could journey through it? Not just through space but through time itself. Imagine standing beside a mighty Tyrannosaurus Rex, feeling the ground tremble with its every step. Or perhaps you'd prefer a glimpse into the future, to see the marvels or warnings that await humanity. This isn't just a child's fantasy, it's a question that tickles the brains of scientists, philosophers and dreamers alike. The idea of time travel is profound. It challenges our very understanding of reality. The river of time flows seemingly in one direction from the past through the present into the future. We are passengers on this river, carried along by its current. But what if we could build a boat, a vessel to navigate this powerful current? What if we could choose to sail upstream into yesterday, or downstream at a faster pace into tomorrow? This desire to control our temporal destiny is deeply human. It speaks to our curiosity, our regrets, and our hopes. It's a quest as old as storytelling itself, a fundamental yearning to understand our place in the grand cosmic timeline. Let's see what we can discover together. Long before scientists pondered equations, storytellers were voyaging through time. H.G. Wells gave us The Time Machine in 1895. A man, the time traveler, journeying to the year 802,701. He witnessed the Eloi and the Morlocks. This tale ignited a spark. It planted the seed of an idea. Time as a dimension to explore. Science fiction became the lab for time travel. Think of Back to the Future. A DeLorean zipping through decades. It was fun, thrilling, and made us think about paradoxes. What if you changed something crucial in the past? Then there's Doctor Who, a Time Lord in a TARDIS, exploring time and space, battling Daleks and Cybermen. These stories shape our dreams. They fuel our desire to break free from time. Fictional journeys do more than entertain. They allow us to explore the what-ifs. What if you could meet your ancestors? What if you could prevent a tragedy, or witness a historical event firsthand? Science fiction provides a safe space to grapple with the ethical dilemmas, the responsibilities that would come with such incredible power. It lets us imagine the consequences, both wondrous and terrifying. Now let's step from the realm of fiction into the world of science, and when we talk about time, we must talk about Albert Einstein. His theories of relativity revolutionized our understanding of space and time. They are not separate fixed entities. Instead, they are interwoven. They form a four-dimensional fabric called space-time. This fabric can be warped and stretched. Einstein's special theory of relativity showed time as relative. The faster you move through space, the slower you move through time. Imagine you're on a spaceship, zipping along at nearly the speed of light. For you, time would pass normally. But to someone back on Earth, your clock would appear to be ticking slowly. This is time dilation. It's real. Astronauts on the International Space Station age slightly slower. The difference is tiny but measurable. It confirms Einstein's predictions. Einstein's theories opened up another tantalizing possibility, the idea of wormholes. What are they? Imagine space-time as a giant sheet of paper. To get from one point on the paper to another, you might travel across its surface. But what if you could fold the paper, bringing those two distant points very close together? Then you could punch a hole through the folded paper, creating a tunnel, a shortcut. That tunnel is, in essence, what a wormhole proposes to be. A bridge connecting two different points in space-time, or perhaps even two different universes. These are sometimes called Einstein-Rosen bridges, named after Albert Einstein and Nathan Rosen, who first theorized them. If traversable wormholes exist, they could offer a way to travel vast cosmic distances in an instant. Imagine stepping through a portal in your backyard, and emerging in another galaxy, or, more relevant to our topic, at another point in time. Some theories suggest that by manipulating one end of a wormhole, perhaps by accelerating it to near light speed, it could become a gateway to the past or future. A true time machine. However, there are enormous challenges. Big, universe-sized challenges. Let's say, just for a moment, that time travel to the past is possible. You build your machine, you set the dials, and off you go. What happens if you try to change something? This is where we encounter the thorny issue of paradoxes. The most famous of these is the grandfather paradox. Imagine you travel back in time. You meet your own grandfather before he met your grandmother. And through some accident, or perhaps even intentionally, you prevent him from ever meeting her, or worse, you cause his demise. If your grandfather never meets your grandmother, then one of your parents is never born. And if your parent is never born, then you are never born. But if you were never born, how could you have traveled back in time to interfere with your grandfather in the first place? It's a mind-bending loop. A contradiction that seems to make changing the past logically impossible. The very act of changing the past would erase the cause of that change. It's like trying to pull yourself up by your own bootstraps while floating in space. It just doesn't work. Scientists and philosophers have proposed various ways to resolve such paradoxes. One idea is that the timeline is somehow self-correcting. What if the grandfather paradox isn't a dead end? What if there's another way to think about changing the past? This brings us to one of the most mind-boggling concepts in modern physics, the multiverse. The many-worlds interpretation of quantum mechanics, first proposed by Hugh Everett III, suggests something truly astonishing. It suggests that every time a quantum measurement is made, or a choice is made, the universe splits. It branches off into multiple parallel universes, each one representing a different possible outcome. Think about that. An infinite number of universes coexisting alongside our own, each one slightly different based on different choices and quantum events. In one universe you turned left this morning, in another you turned right, in one that electron spun up, in another it spun down. If this is true, then traveling to the past might not mean traveling to past. Instead, you might be traveling to the past of a parallel universe. A universe that was identical to yours up until the moment you arrived. In this scenario, if you went back and prevented your grandfather from meeting your grandmother, you wouldn't erase your own existence. Why? Because you'd be creating a new branch of reality, a new timeline where you were never born in universe, but your original universe, the one you came from, would remain unchanged. If time travel into the past is possible, even in some limited way, it leads to a rather obvious question. A question famously posed by physicist Enrico Fermi in the context of aliens: where is everybody? If future humans or even aliens develop time travel, why haven't we seen them? Why aren't there hordes of time tourists visiting historical events, taking selfies with dinosaurs or attending the crucifixion of Christ, or even just subtly observing us from the shadows? The apparent absence of time travelers is a puzzle. The renowned physicist Stephen Hawking was intrigued by this. He even conducted a playful experiment. In 2009, he threw a party specifically for time travelers from the future. He sent out invitations, but only the party had already taken place. His reasoning was clever. If time travel to the past was possible, future time travelers could read the invitation and show up. He waited. Champagne was chilled, balloons were up, but no one came. Does this prove time travel to the past is impossible? Not definitively, but it's certainly suggestive. There could be many reasons for their apparent absence. Perhaps time travel to the past is simply impossible, forbidden by the laws of physics. While building a full-fledged DeLorean or TARDIS might still be firmly in the realm of science fiction, scientists are not idle. They are actively exploring the fundamental nature of time and space, pushing the boundaries of our knowledge in ways that could, one day, shed more light on time travel's feasibility. Particle accelerators, like the Large Hadron Collider at CERN, are essentially time machines of a sort. They accelerate particles to incredible speeds, very close to the speed of light, and we observe time dilation effects on these particles, exactly as Einstein predicted. These experiments help us understand the behavior of matter and energy under extreme conditions. They probe the very fabric of space-time. Scientists are also searching for exotic phenomena, things like magnetic monopoles or extra dimensions of space, which some theories predict. Discoveries in these areas could revolutionize our understanding of physics, and potentially open up new avenues for considering time travel. We're also listening to the universe. Observatories like LIGO and Virgo detect gravitational waves, ripples in space-time caused by cataclysmic events like black holes merging. Studying these waves gives us new insights into gravity and the structure of space-time itself. It's a new way to see the universe. So, where does all this leave us? Is time travel fact, or is it destined to remain fiction? The honest answer as of today, May 24, 2025, is that we don't know for sure. Time travel into the future in a limited sense is a proven fact. Thanks to Einstein's theories of relativity, if you want to travel into Earth's distant future, get on a very fast spaceship, or hang out near a very massive object. That's a one-way trip though. Returning to your own time is the much harder, perhaps impossible part. Time travel into the past is far more speculative. It's fraught with paradoxes and requires conditions that seem, for now, beyond our reach. Wormholes, exotic matter, manipulating space-time on an unimaginable scale. These are colossal hurdles. The laws of physics, as we currently understand them, don't explicitly forbid it, but they don't offer an easy roadmap either. The universe is under no obligation to make sense to us, or to fulfill our science fiction dreams. It simply is what it is. The path forward lies in continued scientific inquiry, in pushing the boundaries of theoretical physics, in building more powerful experiments to test our ideas. We need to understand quantum gravity. We need to explore the extreme corners of the cosmos.